Okay, today's webinar is on duct smoke detection. We're going to look at both the codes that are involved in most communities as well as the actual product itself. At TEC here, we represent the system sensor line of duct smoke detectors. All right, so the first thing is, why do we even bother sensing smoke in ducts? There's two main reasons that we do it. One is for the safety of people, right? We don't want people to be stuck and caught in a fire, and this is one of the many methods we use in a building for early detection of a fire. And the other thing is to protect the actual property involved. That's both the building, the walls, furniture, things like that, as well as the mechanical systems themselves. Air duct systems are a great transfer media to move the smoke around the building and also provide fresh oxygen to fires. So we definitely want to shut down the fan systems in the event of a smoke or fire condition so we don't continue to move all that smoke around the building. So there's numerous different codes and standards that could be involved in here depending on what your local authority having jurisdiction decides they want to do. And because this kind of bridges the gap between fire code and mechanical code, there can be multiple codes in play, and you will have to comply with all the codes, not just the one you think is the best. The major code that's usually involved is NFPA, National Fire Protection Association. We'll talk about that. And the other one that comes into play quite a bit with duct smoke detection is the International Mechanical Code, IMC. Additionally, local jurisdictions, various towns and villages might adopt their own fire codes, or they might adopt the NFPA or the IMC and modify it, or add things to it, or take the best of both kind of thing. So there's lots of different things that could happen in a given community, and you need to check and see what the code is for that community. What we're going to talk about today is just explaining what the standard model codes would require. So the first thing that comes up quite a bit is, when do I have to use a duct smoke detector, and where do I locate it? The basic rule of thumb is 2,000 CFM. Both NFPA and IMC hinge on that volume of air, 2,000 CFM, which is approximately a 5-ton rooftop or air handler. We'll talk about IMC in a minute, but the NFPA requires that you mount the smoke detector in the supply side of the system. So that would be after the heating and cooling sections, after the fan. The very last thing in the system before air is delivered down the duct would be the smoke detector. It can be located inside the rooftop unit, or it can be located in the supply duct system itself. Once you get up to about 15,000 CFM, then you are required to put a smoke detector in both the supply and the return duct. So you will have to use two of them on larger air handlers. And then the main goal of these duct smoke detectors, like I said, is to sense the smoke in the duct and prevent that smoke from circulating through the building, or prevent new oxygen from being brought into the building to provide oxygen to a fire that's already burning. So the way that we prevent that from happening is by shutting down the supply fan, return fan, and exhaust fan associated with that rooftop or air handler. So once the detector detects smoke, then it disables the power to those fan systems inside the air handler. Additionally, what we often do, although it's not required by code generally, but we often shut the outside and exhaust dampers. There's no reason to continue to bring air into the building to feed flames, and also we don't want the equipment to freeze or anything like that. And then if it is hydronic heating and cooling, we open up those valves. We open up the hot water valve, we open up the chill water valve to prevent those lines from freezing with any outside air that's leaking in. The requirement to do the duct smoke detection is there even if that particular building size and usage does not require a fire alarm system. So the duct smoke detection requirement and the fire alarm system requirement are independent of one another. You have to do the duct smoke detection on every single building that is following NFPA, which is the vast majority of buildings. If the building is following the International Mechanical Code, now remember, it could be following the IMC by itself or at the same time as NFPA. That code also looks at 2,000 CFM, and that is the requirement for a duct smoke detector to be installed. However, the IMC requires it to be installed in the return air duct. So NFPA requires it in the supply, IMC requires it in the return. Both of them look for pieces of equipment that are 2,000 CFM. And actually, it's not even pieces of equipment, it's systems. So if you happen to have two small units twinned together and each one of them is only 1,500 CFM, that doesn't mean you don't have to put the detector in. The 1,500 units to twin together is really 3,000 CFM for the system, and hence you have to put the duct smoke detector in. So IMC requires it on the return duct. The NFPA requires it on the supply duct. When you get to 15,000 CFM, you would be doing it on both ducts. Additionally, the IMC, like we said, it has a requirement for putting a smoke detector in the return duct itself. But if you're doing it in a larger system, so if you have a multi-story building, 2, 3, 4, 5, 10 stories, whatever it's going to be, and that system is serving a portion of the return air system that has 15,000 CFM or more, then you need to install it on each floor that it's being supplied to, each story. That doesn't happen on a lot of projects. Obviously, it's a pretty unique job that you got 15,000 CFM, multiple stories. But if you do, you need to have a return duct for each floor of that return duct system. And then, like I said, if you are in a jurisdiction that's requiring both the IMC and NFPA, then you will have to put 2 detectors in for 2,000 through 15,000 CFM because you're trying to comply with both codes, supply sensing for NFPA, return sensing for IMC. So you might have to do both. So what happens if you're in a jurisdiction that does not require either NFPA or IMC? Does that mean you don't need to put a duct smoke detector in? Some of you probably would argue yes, that means you don't have to do it. But when something happens in the building and that air handler does not shut down and then continues to propagate smoke to the building, you're probably not going to be very happy at the result when you get sued because you didn't follow the general standard of care. The standard of care is either one of these 2 codes that requires you to put a duct detector in at 2,000 CFM. So even if no one's forcing you to do it, you probably should design your building that way, or you're going to be the one that's liable later when there's a problem. Because the standard of care is to do it, even if the fire department doesn't force your hand to do it. We do get a lot of questions about whether the duct detector needs to be powered off of the UPS backup power system, because many of you know that the fire alarm systems generally are on the UPS. The duct detector does not have to be powered up on the UPS if his whole job in life is to just shut down the HVAC fan. Then he does not have to do it. So if he's getting his power, the duct detector is getting power from the same exact power source as the HVAC fan, and his job is to just shut him down, you don't have to put him on backup power. The idea there being that if the HVAC fan loses power, he's already going to be off, so it didn't matter. If the duct detector is powered off the fire alarm system on a more robust control system, then you would have to put it on the UPS because now the duct detector has a different power source than the supply fan. If you guys have questions as we go, down in the bottom right-hand corner of your screen, you'll see a question/chat box. You can type them in there, and I'll do my best to answer them as we go. And if I can't answer them as we go, then I'll follow up with you and answer them after the fact. So that kind of gives you the summary of when you have to do this by code. Basically 2,000 CFM, you need to put one in, either the supply or the return duct, depending on which code you're going to follow. 15,000 CFM, you need to do on both. So if you have a system that's following NFPA and it's a system where there is no fire alarm system required, meaning you don't have all the sensors up in the ceiling that are all tied together with the hand pull switches and all that. You don't have that in this little tiny building. It's just a little, whatever, 2,000 square foot doctor's office or something. You don't have that fire alarm system. You still do have to put the duct smoke detector in. And that detector must then provide both a audible sound alarm and a visual alarm in the occupied space. So not only does he have to shut down the fan systems in the air handling equipment, but he also has to alert the occupants in the space. So if there's smoke detected, then they'll be notified so they can then leave the building. A trouble signal, which means that I have multiple detectors tied together for different systems, and one of them is getting a signal from the other one, or because they lost power or something like that, then I have to create either a visual or an audible alarm in the space. So if it's actually in fire mode, I have to do both. If it's just a trouble alert signal, I have to do one or the other. You're not required to activate the building evacuation alarm. You're just required to make notification in that particular occupied space. So if rooftop number 3 trips on smoke detection, the little horn buzzer and flashing light down in zone 3 has to flash and alert the occupants, but it does not have to trigger the full building evacuation alarm for all the other buildings and floors. On the flip side, if I am putting a duct smoke detector in a building that does have a fire alarm system required by NFPA, then I do have to connect that duct smoke detector to the fire alarm system. There are numerous ways to do that. The most common is just through the trouble contacts circuit, so that way when one of the smoke detectors trip, the fire alarm panel is notified of that. And then I have to initiate either an alarm signal in the occupied area, in the protected area, or a supervisory signal back at a monitoring station that's occupied 24/7, so like a guard station or something like that. The most common way to do it would be in the occupied area. All right, so one of the times that NFPA 90A does not require duct detectors. Does not require them if the entire space that's served by that air handling system is protected by its own area smoke detector system, although it still would be good practice to put it in. It does not require them on fan systems whose whole sole function is to exhaust air out of the building to the outdoor air. So you don't have to put it on exhaust systems if that fan is dedicated for exhaust only. However, if that exhaust fan is part of an air handling system and that some of that air is going to go out the exhaust and some of it's going to go in the return, then you got to do it. If it's just straight up 100% exhaust all the time, then you do not have to. And then the third time you would not have to do it is if you have an engineered smoke control system. And that's underlined because that's not something most buildings would have. It's for a much more robust application, and you're probably going to end up still seeing it there because that guy's probably going to engineer it that way anyway. But those are the times that you would not be required by code to do it. So general rule of thumb, if you got 2,000 CFM, you're probably putting one in. There's a few things that the duct detector doesn't do, right? We already said that his job is to detect smoke in the air handling system and shut down that air handler so it doesn't spread the smoke or spread new air to the existing fire. What it cannot do is it cannot be a substitute for the area smoke detectors. These are all the detectors that are installed up in the ceiling typically or on the high walls. It doesn't replace those. It's not like you could say, oh, I'm going to not buy 30 of these space detection sensors because I got this one return duct sensor and you can cheap out on the thing. That's not what this is for. This is just to shut down the mechanical equipment. It is a supplement to the space smoke detectors. It is no substitute for them. So you still have to do the regular fire alarm system. So smoke detectors can only do a good job of detecting smoke, obviously, when air is in the ductwork. So if the air handler is off, it's not going to do a very good job of detecting smoke, which is why you don't use this as a substitute for the regular space detectors, and they can't match their ability. And they also don't do a very good job when the filters are all plugged up and dirty. It restricts airflow, which limits the amount of air being brought over to the smoke detector, which makes it take longer to actually detect something. This is what a typical smoke detector looks like. Actually, we got a quick question that came up. David is asking if there's an archive webinar for later review. The answer to that is yes. Some of you guys may have missed that quite at the beginning, but this webinar is being recorded and it will be posted online. If you need help finding that later, send me an email and I will direct you to the link. That way you or your coworkers can watch it later. So this is what a detector typically looks like when you take it apart. Hopefully you guys can see my mouse. I believe that you guys can. So this detector basically has two sides to it. The left side over here is where the detector head is at. That's this circular guy here. His job is to obviously sense the smoke. So this chamber here on the left side is the smoke detection chamber. The section over here on the right-hand side is the electrical section. So this is where all the wiring is going to occur. The power wiring, the alarm wiring, if I got any accessories down on the wall, if I'm connecting it to other detectors, all that wiring is going to happen on the right-hand side. So smoke on the left, electrical on the right-hand side. Both sides get a cover put on them. You can see on the smoke detection side there are two of these sampling tubes here. One of them has holes in it, one of them does not. The one without holes is the exhaust tube. His job is to remove air that's already in the detector. The other tube with the holes in it, his job is to bring air into the detector. So we'll look at those in a little bit more blown up here. So this is a drawing of the sampling tube for the supply side. That exhaust one, the little guy there, he's probably about 3 inches long or so, and he comes shipped with the smoke detector. The sampling tube on the supply side does not. So he's ordered specifically depending on the length of the duct that you're putting it in. These smoke detectors can be used on very small systems or very large systems. It's the exact same SKU, the exact same model number. But the sampling tube ships separately because you need to order that for your system. Generally, you need to have that tube go across the full length of the duct. I think technically by code it only has to go 80% of the way. However, if you got it going 80% of the way, that means there's nothing really supporting it on the other end. So most guys just go all the way across. So for example, if you have a 2-foot wide duct, you would put in a 3-foot tube and you would cut off 1 foot of that tube so it's only 2 foot long. You don't have it sticking out the end of the duct on the other side. However, if you had a, let's say, what's another example? If I had something that, let's say, was a 12-foot duct, I would put in a 10-foot tube because it's the largest one that's available, and that does make it 80% of the way across, then I'm fine. I would have to support it at the other end of the 10 feet because it wouldn't make it all the way across the 12. What if I had a duct that was more than 12 feet long and I couldn't do it with a 10-foot tube? Then I could do it with 2 detectors, one on each side of the duct. If I had a system that was that large, obviously that's a huge system and doesn't come up every day, but I could put multiple detectors in to get the sampling coverage area that I want. The sampling tube itself has a bunch of holes drilled through it. It basically looks like a piece of conduit. It is a piece of conduit with a bunch of holes drilled in it, but they're drilled in specific spots so they get the right sampling rate. And then you face those holes in the direction of the airflow. So the air blows directly into the holes to give the best sensing ability possible. So you can see these arrows come here. They blow the supply duct air or the return duct air directly into these holes. That smoke collects in this sampling tube. It moves along the tube to the end over here where it's connected to the detector, which comes out right here. And that goes into this chamber where the sensor can detect it. And then that pressurized air pushes with the remaining air out this little exhaust tube. So these supply and exhaust tubes, even though we call them supply and exhaust, that doesn't mean they have anything to do with the supply ductwork or the exhaust ductwork. They are the supply and exhaust tubes associated with that sampling section. They both go in the same duct. There's a lot of places that we can mount these guys. The most common one is to mount it on a duct right at the discharge of an air handler or right at the return inlet of the air handler, depending on the code. Sometimes you may also mount them inside packaged rooftop units, and you may order them in some cases from the rooftop manufacturer that way. I know the Carrier guys do supply them that way on larger size units. You can order it like that, and sometimes even smaller ones if you want to do a special order from the factory. You can see this one here in the top right picture. He's mounted at the discharge of the fan, the farthest thing they can do after it's gone through all the other sections. Sometimes you'll also have horizontal rooftops and you won't have anywhere to mount them inside the rooftop cabinet itself, or maybe it's not available from the manufacturer. You can either then mount one indoors inside the ductwork, or like this drawing on the bottom left is showing, you can actually get an outdoor rated version of it to mount it outside. We'll talk more about that in a little bit. And then the last place you might see mounted is at smoke dampers. We don't do a lot of smoke damper work at our office, but other folks do, and these same detectors can be used in those applications, obviously with a much shorter sampling tube in most cases. All right, so that's kind of the basic summary of it. I want to show you a fairly cool detector that the system sensor folks have. It's called Innovair Flex. It's called Flex because it's extremely flexible, and that's kind of what we'll talk about for the next couple of minutes here. The goal of this product when they had designed it was to reduce the installation cost, reduce the amount of SKUs that distributors and contractors need to stock, make it easier to test these things, and reduce the amount of false alarms that you might see on them. So this is the right-hand side, the power side, if you will, where all the wiring happens. One of the differences here is that there's actually 3 different conduit entry points of different sizes, 1/2 inch and 3/4 inch, to make it a little bit easier to install. It's also a more roomier section than we might have had before, so it should be easier to get all these terminals done. The other cool thing about these is that the footprint fits the previous system sensor product line as well as several competitors' lines. So it is very good for retrofit applications. It can fit in multiple spaces. All of the wiring designations match up with the previous system sensor Innovair product, so that way if you happen to be swapping one out, it won't be very confusing. It should be pretty straightforward. And if you are swapping one out and have the old accessories, the old wall accessories, which we'll talk about in a little bit, they are compatible with this newer detector. I say newer, this has probably been out for, I don't even know, maybe 5 years or something like that, 4 or 5 years for this Flex version of it. He is shown here in a rectangular configuration, which is very common and matches up with the previous system sensor products. However, some of their competitors had a vertical orientation or a square orientation. So this one actually, if you take one screw out of him, I don't know if you guys can see that little screw hole right here where my mouse is. If you take that screw out of the back, you can rotate this guy around, put the screw back in, and the exact same product can be used in either orientation. Normally it's not a big deal, but if this guy was butted up against the wall right here or something like that, now you don't have to be forced into buying a certain manufacturer's detector. This one can comply with either space constraint that you have. So it can go either direction. He also can accept multiple power sources. 120 volts AC is a very common choice. He can also run on 24 volts AC or 24 volts DC. He has terminals for both of those types on their 24 or 120. It could be AC or DC on the low voltage side. Same thing's true on the outdoor version. The outdoor version is basically the exact same product with the same wiring label terminations and works the same way, looks and smells like the exact same thing. The difference is that he has a different cover that is UV resistant and he's rated for outdoor usage. So the cover, the plastic itself is white, it's UV resistant, and then the way that the box seals is NEMA 4 rated, which means it's watertight. So it can be installed outdoors. It's not that much more. I want to say off the top of my head it's like $20 more or something than a regular smoke detector. So if you got an outdoor application and you want to do it, the detector will not be cost prohibitive. Now you still got to do all your conduit and watertight connections and all that. So obviously you want to install it indoors when you can, but if you have to put it outside, it's doable. The sampling tubes, this shows you a little bit better picture of one of the sampling tubes being installed. They can be installed from the front of the detector or the back of the detector. So they can be installed either way and they click into place. We've used these for several years now at our office and they're very reliable. I've never had a clip break or anything weird like that. Technically they come in lengths from 1 to 10 feet, although most of the time we're dealing with 3 foot, 5 foot, or 10 foot. And usually it's 3 or 5 for most applications, for most rooftops and smaller air handlers. As you can see there, the sampling tube for the supply side goes on the left hand of the detector. The exhaust one would go right under this gentleman's hand and it would poke through on that side. If you install it from the back, it would look like that. So here's the supply tube going in here. Airflow would be in the direction of these holes, blowing right into the holes, and then that would go into the chamber over here, and then the air would exhaust itself back out this little short one. So just remember, you got to get the sampling tube as a separate line item. The exhaust tube comes with it because it's always the same length. The sampling tube is ordered separately from the detector because you need to specify how long you need it to be. It's got to go at least 80% of the way across the duct, preferably all the way. If you do need to ever change out one of the sensor heads, that's that white piece that's underneath the plastic cover here, they are actually the same sensor heads that are used in the occupant spaces and the ceilings type systems. So if the fire guy has those or stocks those, he can easily put one into one of these guys as a replacement. So it's not like it's two separate things. It's very easy to swap out. All the boards and wiring can stay the same. You just basically unscrew or twist open, you unscrew the cover obviously, and then the white detector, you twist it to the side and then pull it out, put the new one in and twist it into place. So it is fairly easy to replace if you need to do that. It also has a pretty cool feature in it that adjusts its sensitivity or calibrates itself, if you will, to the amount of dust you have in your ambient air. That reduces the amount of false alarm trips that it has. So you should have less nuisance trips, which means that when it does really go off, people believe it, and it also means that you don't have a bunch of extra service calls for nothing. These guys are pretty easy to test. They have all the traditional test methods you have, plus a few other unique ones. The traditional way we've always tested them electrically is with a magnet. If you hold a magnet over the side of the detector, it'll trip the electrical contactor, and then you'll be able to see all your shutdowns happening. You know that you've wired it correctly. There's also a test button on these guys, so that way the fire guy can press those and verify that they all work. And then there's also the option, if you want, depending on which wall accessories you have. Some of them have a little infrared tool you can put up next to them that will then trip the detectors and you can test them. We'll talk about that in a little bit. These guys can be installed pretty much in any duct system that you have in terms of operating conditions for HVAC. It goes all the way down from -4 up to 158 degrees, which is pretty much our normal range. 0 to 95% humidity. That's all normal stuff for both the indoor and outdoor unit. The outdoor unit can also go down to -40 instead of -4, so that guy can have an even better operating range. The really cool thing about these guys is the air velocity range. As you can see on the screen there, it goes from 100 to 4,000 feet per minute. 100 feet per minute is obviously a very low velocity. So these guys, the exact same detector can be used in a standard system or in a low velocity system. Other manufacturers' products over the years would require you to stock and or buy 2 different SKUs for those applications. This guy can do both. So he can go all the way down to 100 feet per minute velocity on low flow systems if you have that kind of system installed. If anybody has any questions, please just type them in the bottom right hand corner of your screen where you see that question chat box, and I'll do my best to answer them. So there's a lot of flexible things involved with this. The voltage is pretty flexible. The way you can install it vertically or horizontally is pretty flexible. Another thing that's pretty flexible about them is that these detectors can be installed, I don't know what's the best way to say it, piecemeal. So if I do have an application where I need to monitor both supply and return systems, which would mean that I have either 15,000 CFM or more, or I have 2,000 CFM or more in a jurisdiction that's regulated by both NFPA and IMC, then I'd have to have 2 detectors. I could obviously buy 2 detectors and wire them both to the fan system so either one of them could shut down the fan system. That's what it's showing up here. I do have 2 other choices. One is to buy a regular detector, which is this guy down here, which in this case is the model number D4120, same as the guys in the top right corner. And then I can also buy a D4S, which is basically just half of that guy, just the detector half, without the power side. And I can wire that detector back to this detector, and then they can have all the same power connections. So the nice thing about that is that I don't have to bring numerous sets of wires to both of these detectors. I can bring them all to one spot and then just have a piggyback wire that goes over to the extra detector. The third way to do it would be to buy just the 2 head sides and then a power side separately. I could have the 1 head in the supply, 1 head in the return duct, and then I could have the power sidebar external from both of them over by the control panel, over by the fan starter. So I got multiple choices on how I could choose to do that. This is showing you a drawing example here of if I have it split. So up here on the return air, I got the regular detector with the regular detection head and the power side. And then on the supply duct work, I just have the detector head, and he's piggyback wired over to the other guy. So those 2 guys will work together as a system. So there's multiple reasons why you might want to do that. 1 is to save a little bit of cost. 2 is to reduce a little bit of wiring. And 3 is if you're going to put a networked smoke detector system in. These 2 together like this would only count as 1 detector on the network. Whereas if I had 2 full detectors on here, it would count as 2, and it would help me hit my maximum faster. The maximum that you can network together and interconnect is 50 units. So that could be 50 different air handlers, or it could be 25 air handlers with 1 on the supply and return each. Or if I was smart, like I said over here, and I did these guys in the piggyback fashion, this only counts as 1. So I could do supply and return on 50 air handlers if I wired them up like this. The advantage of interconnecting these is so that when 1 trips, it can be alerted over to the other units and they can take action on those. So there are reasons you might want to network these guys. These guys are backward compatible with all the existing remote accessories, which are the lights and test stations and things like that. I'll show you some of those in a minute. Plus they have all of the new versions of those that are available, which I'll show you. One of the things to pay attention to when you're installing these is to make sure you're installing them in a location that gets adequate airflow. It used to be that the code recommended a specific number of duct diameters. You had to be away from any elbows or accessories in the duct or T's or anything like that. They took that out of there because apparently that was probably too broad of an answer. And now that they specifically state that you have to install it where you can get an adequate air sample, or where the manufacturer of the equipment suggests that the pressure differential can be actually measured. and then you could obviously use a manometer or a magnehelic gauge to actually measure those. As a rule of thumb, when you're hunting for that spot that's going to give you good airflow, if you follow the duct diameter rule, the old, get at least 5 duct diameters, or in this case, it's showing you 6 to 10 duct diameters away from stuff, the air will be more stable. If you start looking in those places and then use your manometer to measure that you're getting a good airflow rate, that's probably where you want to start looking. You don't want to put any type of sampling devices, whether it's duct smoke detectors or temperature sensors or anything like that, right at the end of an elbow, because the airflow will not be coming through there in a uniform fashion, and you'll get dead pockets where there's actually no air movement at all. So you're better off putting it 5 to 10 duct diameters downstream of any of those objects. On the wiring side of the detectors, it can be a little bit overwhelming if you've never wired one up, because there's all these different detectors and you don't really know what they're for, all these different contacts, excuse me. So we'll try to explain real quick what some of these guys are for. So up at the top, the first section of wiring is for the power choice. Like I said, it can either be 24 volts, AC or DC. It'll detect which one you have. Or it could be 120 volts. You wire one or the other, not both. But it can be powered off either one of those types of power sources depending on what you have available. Then where it says auxiliary contacts, auxiliary sounds like it does something extra, but for HVAC guys like us, auxiliary is the main thing we're concerned about. Our supply fan or our return fan is the auxiliary device that they're talking about. That's where we're going to wire our device up to. We're going to wire it to the normally closed contact. That means if this thing is powered and functional, this contact, this little switch, if you can see where my mouse is at, that little switch is closed. It allows power to flow through that circuit, which allows the supply fan to run. If there is a detection of smoke, then that contact will move from the left contact over to the right contact, which will open up our circuit, which will cause our fan to shut down. For HVAC fans, there's no reason why you'd want to wire it to the normally open scenario. Normally closed would be the fail-safe position. That's where you want to wire it. So normally closed and common. If you had 2 fans, you could wire the second one to the auxiliary B. So if you had 2 fans off of one detector, that's what you could do there. Or if you wanted to alert to some other system, like your building automation system or something like that, you can pick up that second contact. The supervisory contacts, what that does, if something happens on this detector and he detects a trouble condition, like he lost power or something like that, then he would open up this contact right here, which is also normally closed contact. He would open that up, which would break this electrical circuit that goes throughout the whole building and connects all these detectors. And then it can be notified to the fire system or the BAS or both that there's a problem with one of these detectors. The alarm contacts would be for wiring to the fire alarm panel, and those would be normally open. They would close when smoke was detected. So I got auxiliary for shutting down the fans. I got supervisory just for making sure I can get a heartbeat on all these guys to make sure they're still alive, so I know they're all functioning. And then I got the alarm contacts, which actually tells me I actually have an alarm condition, something bad's happening. So the alarm contacts and the auxiliary contacts trigger at the same exact time. One opens to kill the fan, the other closes to alert the alarm. They trigger at the exact same time, and obviously the auxiliary contacts are rated for higher amperage for some of these supply fans. Depending on the amperage of your fan, you may have to go through another relay and or contactor. There are a couple things that you can set on these. There's basically 3 dip switch settings that you can change. One of them is for the cover. If the cover does not close tightly on there, it will not connect and close a little mechanical switch. We obviously want it to close tightly so that sensing chamber can sense all the smoke. So if that cover is not on even or right or screwed all the way in, that switch won't make, and it'll make a trouble alert. You can set that up to happen immediately, or you can set it up to happen after 7 minutes. 7 minutes being the most common way that I have set them up previously. Then I got time to put the cover back on. The other thing you can adjust is you can just tell it whether it has 1 sensor connected to that power board or 2 sensors connected to that same power board. So that was that supply return system that we showed you previously. And then the third one that you can adjust is the shutdown mode on how the auxiliary relay switches. You'll leave that defaulted the way it is. We'll wire it up so that the relay opens up on a fail and does not do anything on a trouble situation. On the front of the cover, It's clear on these guys, so you can see the lights flashing in there. The light is a multicolor LED light, so it can blink to tell you what's going on. So if it's green blinking, that means everything's good. Life's fantastic. I'm sitting here waiting for something to happen. If it is red, that means that the detector is in alarm. Bad things are happening. And if it's amber, that means it's either in trouble or maintenance. Trouble means that it's solid. Maintenance means that it's blinking. So you can kind of see what's going on without taking the cover off and shutting down the system. You can see right through the cover what's happening. The front of these guys also has the test button, so you can test them with a magnet like we used to do, or you can press the button. Either way, your choice. That button also serves as the reset button should you have to come up and reset these guys. After they trip, you do need to reset them manually. It's kind of like a freeze stat. No one wants an auto reset freeze stat because then you don't know that you're about to freeze pipes all the time. You want it to be a manual reset so somebody has to walk up there and see what the heck happened. Same thing on smoke detection. It's a manual reset. After it trips, you need to go up there and reset it after you fix whatever the problem was. Hopefully there was not a real fire. Some of the accessories, like this one I'm showing you here on the bottom right, also have the ability to have test stations built into them. Sometimes the fire department will require this type of device so they can test the detectors from the space as opposed to climbing up on the roof or inside the attic of the building. This particular one I'm showing you here actually supports two sensors, a supply and a return. By turning this key switch, you can either do number 1 or number 2, and then here's the reset button. It also has an add-on circuit board with an LED light you can put in under this plastic cover here, and then it will have a built-in strobe in addition to the test function and the horn function. This shows you all of those that are available. So the one in the top right, that was the one that does 2 detectors with that key switch. Put on detector 1 or 2. You can see right here where the horn would be, and up here would be the flashing light if you put this little LED accessory inside there. The other ones that are fairly common, this RTS 151 key, that is a simple test station with a key switch. These guys are all keyed the same. The fire departments generally already have these keys, so they already know how to use them and all that. You may be required to put those in, or you might be required to put in a test station that does not have a key that runs on a push button. I don't like those because then any Yahoo can push them. So I'd rather have the key one if it's my choice. And you can also buy ones that just have the status light with no test button. And you can also buy separate horns in various colors with or without test lights. But the one on the right there that says Smoke RTS2-AOS, that guy covers you for pretty much all these scenarios. So if you're not sure which one to get, that's probably the one to do. Because it has the light, the horn, the test station, and it does it for both detectors, supply and return. All right, so if you guys have any questions, type them in the chat box, in the question box in the bottom right-hand corner, and I'll try my best to answer them. So kind of summing up some of these things here, the benefits of this particular detector, it can be orientated in a rectangular or square fashion to facilitate retrofit or tight spaces. The same product does both with the removal of one simple screw. You can have 2 sensors slaved together tied to one power board, the power board being the one on the right-hand side here with the yellow writing on it. And then you have 2 sensors per one if you want. Installing the sampling tubes and things like that do not require you to use any tools. You just pop the tubes in. You obviously need a screwdriver to take the front cover off, but that's not a big deal. Actually, you could thumb screw them too, so I guess you don't really have to have a screwdriver. They have all the test functions built into them. You can connect up to 50 of these units together with a pair of wires, so that way they're interconnected so any one of them could alert the others. There is a weather-resistant version available for outdoor use if you have ductwork outside, and that's the only place to put it. It's NEMA 4 rated. We mentioned the low flow already. These guys have an operating range down to all the way 100 feet per minute, which is very low, and up to 4,000 feet per minute, which is very high. This covers all of the normal HVAC systems that you'd ever run into. If you have anything outside that range, it'd be a very, very special system. They do have the ability to calibrate themselves or adjust themselves, I should say, for the amount of dust in your system, so you get less false trips. You eliminate some of that dust burn-off when you fire up your heat exchanger for the first time, so you don't get those kind of false alarms, and you don't get false alarms related to moisture problems like steam humidifiers or cooking in a restaurant or something like that. Installation costs in general have been less than other products that we've used in the past, mainly because of the flexibility of this system. So it is fairly easy to install. The tubes are very easy to put in. Wiring is simplified, so that does help you a little bit. It also helps you if you're going to do a supply return system. The fact that you don't have to buy 2 full detectors, you can buy one of these heads by itself. That reduces the cost a little bit more. And then if you need to install one of these outdoors, the cost savings is pretty good because you don't have to retrofit a NEMA enclosure around a regular detector. This guy's already got the NEMA enclosure built in. We did have a question come up that said, how many smoke detectors can the RTS 151 key remote test station handle? So real quick, that guy is RTS 151 key is this guy right here. That guy does 1 detector. All of these accessories do 1 detector with the exception of the one over here on the right that is RTS 2. That guy does 2 detectors, supply and return. The rest of them is just 1 accessory per detector. So hopefully that answers your question there, Rod. Let's jump back to where we were. We mentioned the false alarm ability by being able to adjust himself for the amount of dust in your ambient air. This does help out quite a bit. Every time you get a false alarm on a smoke detector, whether it's a duct detector or a ceiling detector, that just trains the occupants that it probably isn't real. I probably don't need to do anything. And obviously you get enough of those and people aren't going to respond to them, and then bad things could happen when they don't respond to a real situation. So you want to eliminate those false alarms. It's also a cost problem. You're having somebody come out and verify that the system's okay. Maybe you're paying the fire department to come out there if you have too many nuisance trips. You probably have a contractor coming out there, your own employees. So the less false alarms, the better. You want this thing to alarm when something really happens. Otherwise, you don't even want to know it exists. All right, so that's kind of the summary of these guys. If anybody has any final questions, type them in or contact me after the fact, and I'll do my best to answer them. I'm going to stay online here for a couple minutes just to see if any more questions come in, and then I'll go ahead and stop the recording. And then if anybody needs a link to the recording, let me know. I'll send it to you. If you got somebody in your office that needs to watch it, I'll be happy to do it. And then just make sure you pay attention to air handlers and rooftops, 2,000 CFM and more. You're going to have to do something, either the supply or the return or both. With that, thank you guys for your time.